were not at all able to figure out what this was, but eventually decided that this had to be something real. It had to be volcanoes that were blasting material off of Io.
For Earth-bound scientists like John Spencer, one way to interpret what the volcanoes on Io are made of is to compare them to similar volcanic structures we can see here on Earth. These fresh lavas are made of basalt. The shape of these flows bear an uncanny resemblance to features that Spencer has studied on the surface of Io. Since Voyager, later missions have photographed this festering world in even greater detail. Spencer believes that the volcanoes of Io seem to have erupted the same black lava we can find on Earth. Io is only the size of Earth's moon, yet its largest volcanoes are hundreds of miles across. Because of the low gravity, they spew lava hundreds of miles above Io's surface. Io's close proximity to its parent planet Jupiter exacts a heavy price. As Io orbits around, it's stretched and squeezed by the immense gravitational forces.
The reason there are volcanoes on Io is because Io is very close to Jupiter, and it's distorted quite a lot by Jupiter's gravitational field. Sometimes it's closer to Jupiter, sometimes it's further away. And when it's closer, it's stretched out, and when it's further away, it relaxes. So continually, once every orbit, Io is being squeezed and deformed, and that just puts a lot of heat in the interior. And that heats up the interior to the point where you have volcanoes on the surface.
As Voyager left Io, it captured real moving images of the first active volcanoes we had ever seen beyond the Earth. Voyager's next port of call was Saturn. It had taken the two probes over 3 years to reach here. Even from Earth, the rings are clearly visible, but Voyager discovered that they were wafer thin. They're composed of millions of separate rings, each made of countless fragments of rock and ice. Above them hover strange dark shadows, thought to be grains of dust swarming in Saturn's powerful electromagnetic fields. Slightly smaller than Jupiter, Saturn is still 750 times bigger than Earth. And like Jupiter, it's orbited by its own mini-planetary system of moons. Mimas, Rhea, Dione, with a count of over 18 moons, Saturn has the most moons of all the planets. The Voyagers were only able to spend a few precious hours photographing Saturn and its moons in detail. Carolyn Porco and her colleagues recently videoed their last farewell to a new probe to Saturn, Cassini. They had spent years designing a machine that will spend the rest of its life endlessly orbiting and photographing Saturn.
Cassini will be, once it pulls into orbit around Saturn, will be the farthest outpost that humans have ever dispatched in the solar system. And it will be the closest look at what still is for us a very exotic environment.
6, 5, 4, 3, 2, 1, and liftoff of the Cassini spacecraft on a billion-mile trek to Saturn. We have cleared the tower. Pitch program is in. Roll program is in.
Cassini, this spacecraft that many of us had spent 7 years of our lives working on, designing and building, to see it get launched atop this gleaming white rocket, which rose from the launch pad. And it made this beautiful sweeping arc across the eastern sky, and then it was gone. I mean, it was literally gone. It left the Earth.
Stand by for solid rocket booster separation at 2 minutes. And the Cassini spacecraft is on its way to Saturn.
Named after the 17th century astronomer who first discovered a gap in Saturn's rings, the Cassini probe will arrive in July 2004. Cassini will also visit the largest of Saturn's moons, Titan. This orange orb is wrapped in a thick atmosphere. What lies below is anyone's guess. But there are tantalizing hints its surface may be covered with oceans of methane, crammed with the building blocks of life. Cassini will target and release the Huygens probe towards Titan. This probe is built to withstand landing on either an ocean or solid land. It will transmit back any signs of organic molecules from this unknown world. Voyager 2 reached Uranus early in 1986. It was 9 years since it had left the Earth. Uranus is colored blue because its atmosphere contains traces of methane. It's a featureless, cold world, but Uranus is different from all the rest. It rolls around the sun, spinning on its side, possibly because of a giant impact in its early life. Uranus is encircled by at least 11 incredibly thin rings of ice and dust, which Voyager showed us clearly for the first time. Last of the gas giants was Neptune, a giant blue sphere 2.8 billion miles from Earth. It was August 1989. Voyager had taken 12 years to reach here. It's so far out that it takes Neptune 165 years to orbit the Sun. It was remarkable that Voyager could photograph Neptune at all. Out here, the sunlight is only 1,000th as strong as it is on Earth. Like Jupiter, there is no solid surface. It's all gas, covered in layers of storm clouds. These are the fiercest storms in the solar system. The winds blow across the surface of Neptune at 1,400 miles an hour. Voyager's final task was to visit Neptune's largest moon, Triton. Across its surface were a field of ice volcanoes, where dark frozen nitrogen had spewed out onto the surface from underground. Our solar system had saved up its most bizarre object till last. Its task completed, Voyager left Neptune behind, hanging